It would be impossible to cover every branch, limb, and leaf of the tree of knowledge where critical thought was expressed and used as the foundation for how we see our software organizations and projects today. However, we can briefly cover some of the more pivotal thoughts that were the bedrock of later thinkers, the model creators of the universe we live in. To get an understanding of where some of this all began, we need to go back all the way to the early 17th century, to the time of Galileo. Referred to as the father of modern observational astronomy, Galileo Galilei was convinced that the true science, developing theories of how the world worked, required measuring and quantifying the universe through experiments that could be consistently repeated. And it was this idea, along with his observations of how the larger moons of Jupiter revolved around the planet, that led him to believe, as Copernicus before him, that the Sun and not the Earth was at the center of the solar system. Of course, the heliocentric model ran counter to the common beliefs of the times, and more prominently against the Roman Catholic Church, which held to the belief that man was at the center of the universe. The logic was clear. All other heavenly bodies must revolve around us. To say otherwise was to suggest man was not at the center. Galileo argued with observations and scientific facts, and although there were no factual data to support the Church's view, Galileo was forbidden to write about his theories, was forced to recant his beliefs, and ultimately was kept under house arrest for much of the remainder of his life. But ultimately, Galileo brought into the realm of science what Sir Francis Bacon and others proposed before him, that of using inductive reasoning as the foundation for the scientific method, focusing on deriving principles from facts and repeatable experiments. It was about this time that René Descartes came along, a student of the scientific thinkers such as Galileo who preceded him. Descartes may well be the most influential thinker of his time, setting the groundwork for many intellectuals to follow. Even today, many universities in the Western world still teach classes on his writings of philosophy, mathematics, and biology. The father of modern philosophy, Descartes became famous for his quote, "Cogito ergo sum," or "I think, therefore I am." He also proposed the idea of duality, where he fragmented man into two parts, mind and body. But he was also a mathematician. His greatest achievements in mathematics was the creation of the Cartesian geometry, establishing our Cartesian coordinate system and thus integrating algebra and geometry, which until then had been two separate fields of mathematics. But Descartes' most influential thought had to do with man's perception of himself. It is reportedly while René Descartes, influenced heavily by the writings of Galileo, observing the intricate automata at the royal gardens of Versailles, envisioned the entire universe as a great machine or clock. In this clockwork universe, Descartes theorized that all objects, whether they were planets and stars or people and animal, were really nothing more than complex machines. Machines driven by precise laws of chemistry and physics that were as of yet unknown. And from this, he speculated that if man could unlock these laws, he could in essence predict the future of all things great and small. Then, he profited, man could live without fear, since nothing could ever be hidden from him. Descartes' addition to the belief of a clockwork universe was an essential one. By describing all things as machine, he created the belief that all systems can be functionally decomposed in their constituent parts, and that understanding the parts is what led to an understanding of the system. If one wanted to modify or enhance the system, then one just needed to decompose the system into its functional parts and focus on those parts as a solution. This idea of a clockwork universe was not widely accepted until a brilliant mathematician from England came along. Isaac Newton studied the works of Descartes. Using his Cartesian system of geometry and the notion that the solar system was one great machine, Newton developed the mathematics that would be crucial to explaining his laws of universal gravitation and motion. Among other things, with this new calculus, and building on the scientific methods proposed by Galileo before him, Precise locations and trajectories of heavenly bodies could now be described and therefore accurately predicted for centuries into the future. For the first time, someone had been able to mathematically and precisely state the laws of physics that Descartes had only theorized in his clockwork universe. No longer was the clockwork idea relegated to parlor room discussions. It was now taught in universities and practiced in all the Western sciences. By the mid-1800s, its effects could be felt throughout the Western world. Newton's addition to the development of the clockwork universe paradigm was that he proved scientifically with his calculus what Descartes had only theorized before, at least as applied to astronomical bodies, and thus established the idea of causality. These ideas, as proposed by Descartes and Newton, led Charles Darwin in biology to describe evolution of species through the survival of the fittest, where under the laws of survival the slightest misstep or a misdeed could spell disaster or death to the unwitting. In order to survive the harsh world, man must see himself not only separate from God, but from nature as well. This idea, for example, was depicted in such writings as Punch's 1882 Almanac. Published just before Darwin's death, this image depicts Darwin as the summit of evolution with the title, "Man is but a worm." Summarizing Darwin's contributions to the clockwork universe, then, we can begin to see how man's view of himself and the universe was shifting from that of being the center of the universe during Galileo's time to that of being separate from God as well as nature, attempting to survive the harsh natural effects of pruning the unfit. And of course, this idea was not only applied to people, it was also applied to entire countries, corporations, and business markets.